Hi everyone, today we're going to be doing lesson 6 of unit E. We're going to be looking at the exponent laws for multiplying and dividing. The first part of the first question asks us to look at x to the power 7 multiplied by x to the power 4. If we imagine what this would look like expanded, we would see that it would be x multiplied 7 times and then x multiplied 4 times. If we were to multiply those together, we would have x to the power of 11. This could also be found by adding the exponents. We have the same basis here, the x, so we can add the exponents to get x to the power of 11. Similarly, the second part of this question has us doing x to the power of 7 divided by x to the power of 4. We can see what this would look like if we were to expand it. We would have a fraction with 7 x's being multiplied together on the top and 4 x's being multiplied together on the bottom. We'd be able to cancel out a bunch of these x's or divide them out, which would leave us with x to the power of 3. We could find this as a shortcut by doing x to the power of 7 minus 4, which would give us x to the power of 3. Question 2 has x to the power of 6 multiplied by x. We know that when we have a variable on its own, it's actually x to the power of 1. So we can use the exponent law for multiplying here, and we can keep the base the same and add those two exponents. So we'll have x to the power of 6 plus 1, which is the same as x to the power of 7. Similarly, with the second part of this question, we have x to the power of 6 being divided by x to the power of 1. We'll subtract those exponents, and we'll have x to the power of 6 minus 1, or x to the power of 5. We have another opportunity to apply the exponent laws here. In the first part, we'll have x to the power of 9 multiplied by x to the power of 4. We can add those exponents to have x to the power of 9 plus 4, or x to the power of 13. The second part of this question has x to the power of 9 divided by x to the power of 4, so we'll subtract the exponents. Keeping the base the same, we'll have x to the power of 9 minus 4, or x to the power of 5. Question number 4 adds some coefficients into the mix. In the first part, we have 8x to the power of 7 multiplied by 4x to the power of 3. We'll need to multiply the coefficients together. 8 times 4 will give us 32. And then we'll keep the base the same, and we'll add the exponents because they're being multiplied. So it will be x to the power of 7 plus 3, or x to the power of 10. Altogether, we'll have 32x to the power of 10. The second part of this question has 8x to the power of 7 divided by 4x to the power of 3. As when we multiplied, we're going to need to deal with the coefficients first. So we'll do 8 divided by 4. This will give us 2. For the power part of our answer, we'll have x to the power of 7 subtract the 3. This will give us x to the power of 4. So altogether, we'll have 2x to the power of 4. Now in this question, we have a second variable in the mix. We'll have to recognize that we have to have the same bases in order to be able to apply the exponent laws. So in the first part of this question, the x to the power of 4 can be multiplied with the x to the power of 3. This will be x to the power of 4 plus 3, or x to the power of 7. In terms of the y part, we'll do y to the power of 6 multiplied by y to the power of 6, which will be the same thing as y to the power of 6 plus 6, or y to the power of 12. This will give us a final answer of x to the power of 7, y to the power of 12. The second part of this question has us doing the same kind of idea, except we'll be dividing, which means we'll be subtracting the exponents. So we'll deal with the x to the power of 4 divided by the x to the power of 3 first. This will be like x to the power of 4 minus 3, which is just an x. In terms of the y's, we'll have y to the power of 6 divided by y to the power of 6, which is the same thing as y to the power of 0. Of course, y to the power of 0 can be simplified. We know that anything to the power of 0 is 1. So our final answer will just be x to the power of 1, or just x. This will be multiplied by 1, which will just remain as x times 1, or just x. This question has a little mix of everything. We've got some coefficients and we've got two different variables. So we'll handle them like we have in the previous examples. We'll deal with the coefficients in the multiplying by doing 6 multiplied by 6. That'll give us 36. We'll deal with the x because we'll go x to the power of 4 times x to the power of 3, which will give us x to the power of 4 plus 3, or x to the power of 7. In terms of the y's, we'll have y to the power of 6 multiplied by y to the power of 6, or y to the power of 6 plus 6, which is y to the power of 12. Altogether, we'll have 36, x to the power of 7, y to the power of 12. When we divide, we'll handle things in a similar way. We will do 6 divided by 6, which will give us 1. We'll do x to the power of 4 divided by x to the power of 3, which is the same thing as x to the power of 4 minus 3, or just x. And then with the y's, we'll do y to the power of 6 divided by y to the power of 6, which is the same as y to the power of 6, take away 6, or y to the power of 0. Y to the power of 0 is, of course, the same thing as 1. So we can multiply 1 times x to the power of 1, or just x, multiplied by 1, and we'll get a final simplified answer of just x. Good luck with your work with exponents. Remember that when you're multiplying or dividing powers that have the same base, when multiplying, you'll keep the base the same and add the exponents, and when dividing, you'll keep the base the same but subtract the exponents.